Hey everyone, welcome to Duality Repair. I'm going to be looking at my own B&K Precision 1477 oscilloscope. This scope has served me well for the better part of 2 years. However, I don't have any information on the maintenance history, and I've never worked on it myself, so I thought I'd take this time to give it a tune-up if I can. It's been functioning pretty well lately. I think I only see one minor problem, so I'm on channel A here and I'm hooked up to the calibration trace. Really, the only problem is just a little bit of noise at the counterclockwise end of travel. You can see a little bit of noise there as I move it. The counterclockwise end is pretty smooth, and I don't feel any resistance or roughness as I'm moving the knob. It's just the electrical noise there. So I think that'll just need a little bit of a contact cleaner on that knob, and I'll do the same for the channel B's position knob, although it doesn't show quite that much noise. That's pretty much the only problem that I see. Triggers pretty well, and the traces are both really nice and clean, and everything else looks pretty good on them. The thing I'll want to do while I have the unit open, first of all, is just out of curiosity, take a look around and check the layout of this. I've never worked on one of these before. I do have the service manual, so I'll be able to do some pretty in-depth work if I need to. I'll inspect all of the boards for any signs of leaked or bulging capacitors, and I'll spot check some of them for their ESR to see if any of them need to be replaced. If it looks like they're all original or they're all really old, I may recap the entire unit anyway, just to keep this thing running, as this is my only scope and I want it to last as long as it possibly can. So next I'm going to open it up and we'll take a look around. And here we are inside the scope. This thing is as close to immaculate as I think it could possibly be. I hardly see any dust bunnies. All of the boards look to be in tremendous shape. I don't see any signs of anybody tampering or replacing any components on here so far. I'll have to take a deeper dive into each board as we get to them, but so far it looks to be in really good shape. So hats off to all of the previous owners, however many there may have been, for taking such good care of this thing. Let's take a quick look around before we dive into each individual board. So obviously we have the CRT here with this black shielding covering it, and then we just have 3 boards. So we have the power supply board in the back with obviously the main transformer here. On the side here we have the sweep board, and then on the bottom the vertical amplification board. So we'll work on each board individually. I'll start with the power supply board. I originally thought this was going to be a real big pain to get this thing out, because not only do I have to remove it from this frame here, which wouldn't have been too bad on its own, but I also think I would have had to remove this transformer as well as remove this bottom cover in order to clear the end of the CRT. You can see the end of the CRT ends right here. So there's about 2 inches of clearance that I would need. It didn't really seem feasible, but luckily it looks like this whole frame that this board is mounted to will separate from the chassis independently. There's just a few screws on this side, a few screws on the other, and probably a few on the bottom. This whole thing should separate after, of course, I disconnect all of the connectors coming from the 2 boards in the front. You can see some of the wires from the bottom here. They all roll out to the power supply board. So I'll have to disconnect there, and then I should be able to separate it before we can work on it. Okay, it wasn't too difficult to remove the power supply board from the unit. Let's take a look around and make a few notes on the general condition of the board before we look at the circuitry. Looking at the components and the solder joints, I was able to confirm that all of these components are original, which is astounding based on the age of this unit. It's 30 plus years old. Just astounding. Another note, one thing I was originally worried about was this glue here. You can see the glue on the bottoms of the capacitors. I was worried about this because some glue over time, especially over several decades, can become conductive. But I verified with a multimeter that this is not conductive, so that's not a problem. And then another note is I inspected all of these solder joints here, and they're all in really good shape. I don't see any signs of cracks. They're not even dull. They're pretty shiny, so I don't think I'm going to have to touch these up at all, which is good news. To be honest, even though it's good practice, if I try to touch all of these up, I'd probably end up causing a problem that wasn't there to begin with, so I'm going to leave those alone. Now the individual circuitry itself, there's 3 basic sections of this. So the first section is on the left half of the board, and this is the power supply section. It's going to supply most of the voltages for the board and the unit, with the exception of 1 or 2 CRT voltages. This upper right quadrant here is the vertical amplification section. It's going to amplify the vertical signal before it's sent to the vertical deflection plates in the CRT. And this bottom right quadrant, outlined by this white line on the board here, is a DC to DC converter. You can see the transformer here. The function of this is to supply high voltage to the CRT. So we can walk through a little bit of the circuitry individually. We'll start in the power supply section on the left. We have the power coming in from the mains here. It's going to go to the power switch in the front through this connector and come back into the board through this connector. It'll go through the fuse here into the transformer from this connector. It'll come out of the transformer at this connector where it'll enter the board. Now you can see there's 3 bridge rectifiers here. There's 3 different taps on the transformer. So there's 3 separate rails coming from the transformer. You can see up here we have an assortment of electrolytics. This is going to filter the voltages from each individual rail. We have several transistors around the board here, around this section, and a couple down here. These are going to regulate the voltages. We have this package here. I'm really glad this is functioning because I don't know if they make this package anymore. This is a dual op amp. I'm used to the 8-pin dip, so I'm really glad that that's functioning. I don't know if they make an op amp with a package like that anymore. So it's good that that's functioning. So that's the power supply section. Obviously, of most concern is going to be the electrolytic capacitors. Those are all going to be replaced as they're all original, and they're 85C rated anyway, so they should be replaced. We'll move on to the upper quadrant. Again, that was the vertical amplification section. Really, the only thing to note here is you can see the 4 transistors here that are mounted to the heat sinks. These are going to be the amplifiers of the vertical signal, which is why they're mounted to the heat sinks. They have a high supply voltage, and they're going to have a lot of current running through them, and so they need to be kept cool to prolong their life. And then we'll move on down to the bottom quadrant here. This is the DC to DC converter, which is going to supply the high voltage to the CRT. So we have this inductor and capacitor here. This is going to be part of an oscillator circuit, which is going to drive this transistor here. You can't see it, it's just a heat sink. It's a transistor mounted to that heat sink. You can't see it there either. And it's going to drive this transformer, the primary of the transformer, and then the secondary obviously is going to supply the high voltage to the CRT. So with the board in such good shape, you might ask, well, why do we need to do anything with it? If it ain't broke, don't fix it, right? Well, with a board this age, it's always a good idea to replace electrolytics. Even if they test well now, they could fail at any moment. And so I did measure the ESR of all of these capacitors. I believe there are 11. Most of them are in spec, a few of them are near the spec, and 2 of them are failing. So this one right here is failing fairly badly. This is the filter capacitor for the 195 volt rail, so not surprising that it's failing. And then this odd one down here, and I say odd because it's not the radial style like this, the standard style, but it's axial, so it's got a pin on either end. This one's also failing really badly. The spec is something like 20 ohms, and it's measuring something like 80 ohms, so really badly. These 2 absolutely need to be replaced. Since I'm replacing them and due to the age of the board, and since I don't want to come back in here, I'm going to replace all of them. So the caps are on order. They'll be here soon. And the only other thing I really wanted to do as far as preventive maintenance wise is to remove the thermal compound between each of the transistors and the heat sinks and reapply new thermal compound. The reason, again, due to age, the thermal compound, you can see the white on there, and you're not going to be able to tell what I'm doing, but it's really brittle. It's no longer it's no longer liquid at all. It's really hard, and it's not going to maintain its thermal conductivity much longer, if it is even now. So it's really important to keep the transistors that are mounted to heat sinks cool. So it'll be important to remove that thermal compound and reapply new thermal compound. So I will be back once I have the new capacitors installed and I have all of the heat sinks cleaned and new thermal compound reapplied. I reapplied the thermal paste on all of the 6 transistors that are mounted to heat sinks. I have the new capacitors in. You can see the old ones are in the back and the new ones are in the front. 2 things to note. Obviously, you can see the size difference on the new ones. They're all significantly smaller with the exception of the radial one over here and maybe this 1000 microfarads. Not too much smaller than the old one, but other than that, look at the difference in this biggest one here. So again, this is a 47 microfarad at 250 volt, and this is an exact equal 47 microfarad at 250 volts. Higher temperature rating, even 105 C versus 85, so much smaller. It's amazing what the new capacitors can do. And then ESR, so again, I mentioned two of them failed. This is the one that should have been 0.6 or less, 0.6 ohms or less. You can see that is reading 2. That's the same as what it was reading in circuit, about 2 ohms. And a little disappointed to see that the new one is reading better, but it's still actually out of spec, which is disappointing. And I got two of these of the same value, and they're both reading that. Something like 1.6, 1.8. So slightly better, but still out of spec. I don't know. Still going to replace it since it's brand new. And the other one, the radio one, this one, again, the spec is 20, no greater than 20 ohms, and it's reading really high, 78 ohms. And at least this new radio one is reading well in spec, at least much better than that one, 20 ohms. This is a higher voltage rating. The old one is rated at 250 volts. The new one is rated at 350 volts. I couldn't find a 250 volt radio at 1 microfarad, so that's what I had to go with. But, so here are the new capacitors. I'm going to get them installed, and I'm going to reinstall the board, and I'll be back. Alright, it was a bit of a hassle, but I was able to remove the sweep board from the unit. As you can see, I had to remove this front panel here, as well as the CRT screen. And I had to remove all of these nuts as well. There were nuts on almost all of these knobs. Just to get this board out, I had to desolder one of the potentiometers, since the way it was mounted in the chassis would not have come loose otherwise. So I desoldered it and removed it from the board. And here it is. So let's take a look around. Again, this looks to be in good condition. All the solder joints look to be unharmed, no cracks, which is good. And the capacitors are all original again, and they're 85C, so these will all be replaced, and I will check the ESR of all of those and compare them to the new ones just to see how much of an improvement we can expect with just the capacitor replacement alone. So we can take a look around the board a little bit. Obviously, again, this is the sweep board, so it's, among other things, responsible for controlling the sweep timing and the sweep signal to the CRT, the horizontal deflection plates. So we only have 4 connectors on here. So this connector over here on the left, these pins here, is the power input. So this is going to be a power input from the power supply. This adjacent connector here is kind of interesting. So this connector looks like it goes to the vertical amplification board, and it actually supplies voltage or power from this board to that board. So it's kind of a throughput. So we have power supply coming in to this connector, and then we have more power coming out from this connector to the vertical amplification board. Interesting. We have this connector up top, which is going to share the clock signal between the vertical amplification board and this board. And the connector down here on the bottom, which is going to share the signal, so channel A, channel B, and the ground signals between, again, the vertical amplification board and this board. We have some familiar components. This component right here in the middle is going to be the sweep generator. It's a flip-flop. A whole bunch of transistors. All of these transistors are going to be responsible for amplifying the sweep signal, with the final transistors here, these biggest ones, are going to be the final outputs or the final amplifications. And then we have these 2 posts here, right here and right here. These are going to be the posts that send the signal directly to the CRT horizontal deflection plates. And we have a few switches and knobs. So these knobs are switches right here. This top one is the sync switch, so it's you can select between positive and negative slope and positive and negative video syncing. And then the bottom one is going to be your source selector, so source or channel A, channel B, or the external. And then of course the top is the sweep. And so that's the one I'm really going to want to focus on. And we have the one on the bottom as well, or the back, and that's the triggering switch or the triggering pot. And that's it. So we obviously have a lot of potentiometers here for adjustments, which we'll go through if we can, if I have the equipment once I'm complete. As far as maintenance, as I said, I'm going to replace all of the capacitors. The other thing I'm going to want to do is take a look at all of these switches and dials here. So these two types of switches I've never had any experience with. I'm going to look at them more closely to see if there's anything I can do to clean them, re-grease them, whatever. I don't think there is, and if there is, I don't think it's necessary, but I'll take a look at that, and I'll do that if necessary. The trigger pot on the back, I'll spray a little contact cleaner in there and work it back and forth and clean that out. And then the sweep knob in the front here, so it's got that pot in the very back. I'll do the same thing. I'll pour some or spray some contact cleaner in there and work it back and forth. That's with this front knob actually. I removed the knob, but that works the back pot there. And then the actual selector switch, you can see it's kind of got two adjacent boards here. And I was thinking of spraying contact cleaner on those as well, but that's it would be overkill. These are just too exposed. It would make a mess. It's unnecessary. So I think what I want to do, if you see how these things work, is you have these contacts here that lead down to the board, and you have this wheel in the front, and the wheel is what's turning. You can see it moving there. And it's difficult to get the light on it, but the contacts are making tracks or grooves on that wheel, and there's a little bit of noise when I change this. So I think if I spray some contact cleaner on a Q-tip and then work it on that wheel, and then work the wheel around a bunch of times and clean it off and maybe repeat, and do this for the front and the back, I think that'll clean that up pretty well, and I'll be able to remove any noise that was there. So that's it for the sweep board. I'm going to get to work. I'll replace the components, I'll clean the switches that I can, and we'll get it installed, and I'll probably want to test it before I move on to the vertical amplification board. The work on the sweep board is just about complete. I say just about because there was an oversight on my part when reading this capacitor here, C202. I did order a 1 microfarad 50 volt electrolytic, but it's actually a non-polarized or bipolar capacitor, so I have to wait for that capacitor to come in. I have ordered it, so before I can finish this board. Otherwise, you can see I've recapped it with all new 105C rated Nichicon direct replacements, and they went in no problem. I measured the ESR of all the old ones and compared them to all the new ones, and some of them, not all of them, were out of spec, and all of the new ones look really good, so I'm happy about that. I was able to clean the sweep knob pretty good. Again, we discussed that wheel earlier. I just ran a Q-tip soaked with contact cleaner along that wheel, and I worked it back and forth, and I did that several times for this side, and I also noticed that there's a wheel on the back side as well. It's kind of hard to see there. So I did the front and back for both, and then I sprayed some contact cleaner in this pot here, worked that back and forth, and as well as this pot, work that back and forth as well. So once I get this new non-polarized capacitor in, I'll install that, and then this board will be ready to install. While I'm waiting for that, I'm going to move on to the next board, the final board, which is the vertical amplification board. Now I have removed it, obviously. This one was really easy, thankfully, to remove. Once you remove all of the nuts from the front faceplate, there's just the two tabs that you have to remove from the back, and then this board slides right out really nice. So let's go over this board quick. From left to right, we have channel A position knob. Again, this is one of the things I definitely want to focus on. It's fairly noisy, at least at one end, so I'm going to want to clean that pretty well. You can see there's two potentiometers here. This front one is the position knob. This back one is actually the DC balance for channel A, and you rotate that by that center pin there, and you just use a flathead. Now that's an actual part of the adjustment procedure, so I don't want to touch that. So I'm just going to want to clean this front pot really well, and I'll work that back and forth. I think the best way to do it is to spray a little cleaner in from the bottom. You can see there's a good opening in the bottom, and then work it back and forth. And of course I'll do the same for channel B's. It's got the same setup. The position pot is in the front and the DC balance is in the back. I'm only going to mess with the position pots. You can see the inputs here, so you have channel A's input here and channel B's here, and you can see they come right here into the board, into this input capacitor. I resoldered those inputs. They were a little flimsy looking, so I resoldered them up pretty well. They look a lot better, a lot more stable and robust. Then we have the selection switches here. So this is the let's see, DC AC ground switches, or levers they call them. So there's one for channel A and channel B. the coupling levers. So again, I'm not going to touch these. I looked at the same type of lever on the sweep board. There's no noise on these, and I don't think it's worth trying to clean those, so I'm going to leave those alone. I'll do the same on these boards, or this board, I'll leave that alone. And then next we have the volts per division knobs for channel A and channel B respectively. These again have the same type of selection switches as the other one. It's got the wheels. These have 3 boards each, or 3 wheels each. The wheels are a lot smaller, but I'm going to clean all 3 of those using the same method with the Q-tip and the contact cleaner and work it back and forth several times. And then I'll clean the pots back here. These are 2 pots adjusted by these front knobs here. So I'll clean those up really well. And then we have the same type of lever selection switch or whatever in the center here. And this is for the, what is this for? Oh, the mode selection. So channel A or channel B or channel A and B, plus minus. Again, I'm going to leave that alone. So I'm going to work these 2 VRs here, and I'll work these 2 selection switches here. And then of course I'll replace all the electrolytics. There's only 7 on this board, so the least invasive work will be on this board. You can see it's pretty symmetrical. We have 2 on either side here, we have 2 up here, and another right here. So I'll replace all 7 of those. I have those, so I'll get those replaced. You can look at the layout of the board a little bit. So again, we have our inputs here and here, and we have our volts per division selection switches here. We have attenuator for channel A here and attenuator for channel B here. And when we have, there's inside here, there's just 2 ICs, IC 101 and IC 102. Those are going to be to handle the selection. So if you want to display channel A or channel B or both, that's going to be done with these 2 ICs in here. We have some transistors back here. You can see several of them, and these are going to be preamplification for that vertical signal. And we have this is actually an IC here, so this is the output IC. This is the final part of the path before the signal is sent out through this connector here to the power supply board, where we saw it has the output section where the final amplification will take place before it's sent to the CRT. So that's about it. I'm going to get to work. I'll replace the capacitors. I'll clean these potentiometers and these switches here, and this board will be ready to go back in. Once I get it back in, I will finish the sweep board work. I'll install that, and then we'll be ready to test. Okay, I'm finally done with all of the work on the scope. I have the scope back in its home. Take a look at all of the capacitors I've replaced. Now let's take a quick look at the performance results. So I have both channel A and channel B hooked up to the calibration port, and if I move channel A's position up and down, you can see there's no noise at all on channel A, and there's no interference with channel B, and I can do the same with channel B's position knob. Again, no noise and no interference with channel A. So that's much improved. The other thing that may be difficult to tell on camera, but I can certainly tell based on experience with using this scope, is that the traces are a lot more focused. So that's a positive result as well. I actually noticed that after I replaced the capacitors in the power supply section. So I'm really happy with the results of this. I think I've definitely prolonged the life of my scope, and I look forward to using it for many more years and in many videos to come. So thanks for watching. We'll see you on the next one.